Hello, Tom from Every Step Calculus, everystepphysics.com. This problem was in a Yahoo answer section for Yahoo Answers, and you can see it. I'm going to read it here. Another one of these is giving me a little trouble. For some reason, I've got some difficulties when it comes to rotating these things across the axes I'm not used to. So anyways, use the shell method to find the volume of the solid generated by revolving it about the x-axis. The equation is x squared equals 4y and y equals 4. Since this is a shell method, I need to write it in terms of 2 pi integral of y equals 0 to y equals 4 of fy times y. So I need to solve for fy. I square root both sides so that the x equals square root of 4y. Do I need to include the negative sign too? What negative sign? Then it's a matter of plugging this stuff in, integrating it, okay? So he does this and then comes up with 51 2 pi. And of course the answer was even more pathetic than this. A little bit better. No answer. Ran out of knowledge or whatever. So I've tried to, incidentally, can you go to the right of this video screen here and click on that right little box with the calculator, and then subscribe to my site to help me out, and of course help you out by seeing other videos that I may generate. When I program, remember, I'm programming this as if I was in class, as if I needed to pass a test. You know, I program what study material I was going to have on that test, and then I'm not going to the back of the chapters and taking the examples out there and programming every one of it. Waste of time. There's 10 million functions to program. So I need to stay with tests, you know. And of course this would probably be in a test, or it would certainly be in a homework maybe. But I program and I give you the concise, exact steps in a very abbreviated manner to solve the problem. And that takes me quite a while to do that, to figure that out, give us all the garbage. For instance, even this is not the formula in the Stewart calculus book. This is the height, this is the radius, and this is h of y in the Stewart system, and then this would be p of y, which is the radius, okay? And the radius changes because of if you have something like revolve around the y equals 6 or something, then the radius changes. So I'll explain that to you, and I do that. I walk you through it with menus in my programs. Only ones in the world do this. No other ones. You can't get it from TI site. You can get a million of these answers on the internet, but you can't take that into a test with you. You can't have it in your purse or your school bag. And you can't bring your computer into the test, but you can bring the TI89 in your test, okay? Or for when you're doing study materials at school. So let's do it. We're going to go index 8 to get to my menu, and I'm going to go up here because we need to go to the bottom of the alphabet here and get to the shell method, because that's what it asks for. There's shell method. Now this is around the x-axis, so that's the horizontal axis, okay? Now you'll notice in the shell that the formulas are different. In other words, for horizontal you get the 2 pi times the integral of p of y times h of y dy. Okay, that's for the integral. In any other ones like disk and washers, that would be around the x-axis is 2 pi times the integral of p of x times h of x dx. Okay, so I don't know why they switch it around, but for whatever reason these are all simple, pathetic functions that they give you here, all set up, you know, to make you think that you're solving something, but it's just stupid puzzles, you know, that calculus does. Calculus solves nothing realistic or nothing useful, okay, in my opinion, after 25 years of studying this crap. So anyways, horizontal, because we're in the x-axis, and you know the x-axis is horizontal, right? Okay, cool. We're on the same page there. Now notice the formula. This is the first thing you write on your page. Remember, calculus is scored on partial credit in the class curve, so whatever you can write down on your test paper, you're going to get 2 or 3 points on it, you know. Well, first of all, you'd have to memorize this formula, okay? Study the shell method and the disk method and the washer method for days to memorize these formulas and come up with it during a test, okay? And then do all the calculations. Py is the radius, hy is the height. Enter the two functions for x, okay? Now notice they give you x squared equals 4y. Well, we need an x value, so we need to square root both sides. And so we get x equals the square root of 4y. So that's what we entered there. If you entered x squared, my program would tell you you're wrong and then take you back to the where you're supposed to enter it and tell you what to do there. Because you need to solve for x. Okay, so, and they trick you like this. You try to make it hard. I have no idea why. You know, it'd be different if they gave you 10 of these problems or easy steps, and you could kind of get used to doing it, and then maybe give you a trick so that you even know why you do that or what happens. So, anyways, you got to solve for x here. Okay, so, and you have to press alpha first in my programs. Alpha, and we're going to do the square root of 4 times y. Close off the parentheses. And I show you what you've entered. Now the calculator, the fabulous program, solves this for you. If you got 4 under the parenthesis, under the radical sign, you bring that out with 2, okay? That makes sense? Yeah. I say it's okay. And we're going to enter alpha 4 for the other y. There's always 2 y functions given, okay? And that's okay. Now you always take the number less the other one. You subtract the 2 functions. Okay, 4 minus 2 square root of y. Okay, mark that on your paper. Now I ask you certain questions because there's several different scenarios. Did they give you anything for the limits? No. Is there anything about the y? If it was about the y, like for instance they said about y equals 8, well then you'd have y minus 8 would be the radius instead of just y like it is, okay, without it. So, but I say no, they didn't give us that. So here's the radius then, y. P of y is equal to y. Write that on your paper. Is a single y equals given? No, there's not a single y equals given. Okay, number 2. So then we go to where we have to solve for the limits. And so when you put the 2 functions together, or multiple, make them equal to each other, and then solve for y. Y equals 4, only 1. Okay. So then I tell you, well, you have to have another one. So I'm going to take you back to the other site, and you're going to press yes, and then enter 0 for the. Remember to press alpha before you enter the 0. I'll show you that in a second here. So we're going to go back to single y equals given. We're going to press yes, and then we're going to enter it, alpha 0. Okay. So now we have y equals 4. So now we've got all the information. We can go and do the calculations. 2 pi times the integral of y, which is p of y, right, times h of y, which is here, dy, over the limits of 0 and 4. We do the calculations. We calculate py times hy and come up with this. We integrate it. which equals this. Write this stuff all down in your paper just like you see it. At y equals 4, you substitute 4 for all the y's in the function. I use quotation marks because the calculator only allows me to do that. So you're going to put parentheses around when you substitute a number for a variable in the function. You put parentheses around it, right? And so here we've substituted 4 for all the y's in the function, and it turns out to be 64 pi over 5. At y equals 0, everything equals 0. And upper minus lower, volume equals 64 pi over 5, or 40.2 cubic units. Pretty neat, huh? Everystepcalculus.com. I have no idea why you're not rushing there to buy these programs right now, but go ahead, study this crap all by yourself, and you have other classes. I don't know why you would waste your time on one of the most useless of all math programs is calculus. And that's what I say. It makes me mad to say that after 25 years of studying it, but that's the truth to me, you know. And I will argue with any professor, any doctor, professor, anybody, okay? So anyways, have a good one.